Hello friends, welcome to my YouTube channel. Today we are here to start a new subject, that is computer networks. We will be covering the syllabus according to IPU for this subject, and let's start by quickly looking at the syllabus once. So we have 4 units as of given by IPU. First unit is all about internet history and main introduction and the physical layer. The second unit will be about the data link layer and the medium access sublayer. Don't worry about it, we'll be covering it in brief, so I'm just telling you the brief introduction. Unit 3 will be about the transmission networks and the network layer, and about subnetworks and subnetting, etc. And unit 4 is very small, it just covers the transport layer. And some of the other important topics are throughput of slotted aloha and pure aloha. So let's begin. So I just wanted to tell you that we'll be covering these topics in the form of question and answers. So let's begin. Our first question is differentiate between circuit switching, packet switching, and message switching. So basically switching is a topic of your second unit. That's where we have switches. So switches is a topic of your unit 2 and we'll be covering it in this question. Differentiate between circuit switching, packet switching, and message switching. So these are the basic 3 types of switching. These are the different methods used in telecommunication networks to transmit data. So let's know about circuit switching. Circuit switching, a dedicated communication path or circuit is established between sender and receiver before data transmission. The entire circuit remains reserved for the duration of the communication session, regardless of whether data is being transmitted or not. The circuit guarantees a fixed bandwidth and constant delay, making it suitable for real-time applications like voice calls. Examples of circuit switch networks include traditional telephone networks. So basically in circuit switching, there is a dedicated path between sender and receiver. It is reserved for all the time during the communication, regardless the data is being transmitted or not. So it guarantees a fixed bandwidth and constant delay, making it suitable for real-time applications. And let's go to packet switching now. Packet switching breaks data into small packets and send them individually over the network. Each packet is labeled with the source and destination address and may take different routes to reach the destination. Packet switching allows for more efficient use of network capacity and supports various types of data, including text, images, and video. The internet is based on packet switching networks like ICP-IP, TCP-IP. So example of packet switching is the internet, of course. Let's now read about the message switching. Message switching involves sending entire message or data over the data units over the network. Messages are stored and forwarded from one node to another until they reach the destination. Message switching was commonly used in early networks, but has been largely replaced by packet switching due to inefficiency. So we can make out that message switching is not really efficient now and it's been replaced by packet switching. So among these 3, packet switching is the most efficient method. Okay. In circuit switching, a dedicated path is made. In packet switching, packets are made and they are sent individually. In message switching, the entire message is sent over the data. Message switching is inefficient. So in summary, circuit switching provides entire path. Packet switching breaks down data into packets for efficient transmission. And message switching sends the entire data through message. Circuit switching is suited for real-time application, while packet switching is widely used in modern networks like the internet. Message switching is an older method that has been mostly replaced. So this is the basic summary that we have given point-wise in the above answer. So yeah, let's move to the next question. Differentiate between narrowband ISDN and broadband ISDN. So what is ISDN? ISDN is Integrated Service Digital Network. So let's see the differentiation. Narrowband ISDN. Narrowband ISDN provides digital transmission of voice, data, and other services over traditional copper telephone lines. So in narrowband ISDN, we use traditional copper lines to transmit our data. It operates at lower bandwidths. So this is an important point. It operates at lower bandwidths, typically up to 128 kilobytes per second, and is primarily designed for voice and low speed data transmission. So these are the important points that I'm doing in bold, and you can refer to it later. Narrowband ISDN offers multiple channels for stimulus communication, such as voice, data, and video, but at relatively slower speed. It uses circuit switching technology, which we just read. What is circuit switching? And is commonly used for basic telephone services and simple data transfer. Now let's read about broadband ISDN. Broadband ISDN offers higher bandwidth capabilities and supports faster transmission rates than narrowband ISDN. It provides data rates ranging from several megabytes per second up to gigabytes per second. So we can notice here that it happens in KB and it supports MB and as well as GB. So you can imagine how bigger its range is as compared to narrowband ISDN. Broadband ISDN enables the transmission of multimedia, high quality video and other bandwidth intensive application. Like वो तो होना ही है, like समझ रहे हो, बिकॉज narrowband ISDN की रेंज अगर इतने कम है तो broadband ISDN ऑफ कोर्स अगर उसकी रेंज इतनी ज़्यादा है तो मेन सारे क्वालिटी वीडियोस एंड लाइक सारे मल्टीमीडिया हमारे इसी से ट्रांसफ़र होंगे. इट यूजेस पैकेट स्विचिंग टेक्नोलॉजी. सो ये चीज़ याद रखने की है. narrowband ISDN में हमने देखा कि सर्किट स्विचिंग टेक्नोलॉजी यूज होती है, whereas broadband ISDN में packet switching technology use होती है, allowing more efficient use of network resources and flexible allocation of bandwidth. Broadband ISDN is suitable for higher speed internet access, video conferencing, and advanced data services. So yeah, let's move on to now the question 3. Discuss the various issues in designing data layer in detail. सो आई कैन से कि एक इम्पॉर्टेंट क्वेश्चन है, इसको ज़रूर पढ़ के जाना, मतलब समझ के जाना ध्यान से. सो दीज आर सम की इशूज दैट आई हैव मेंशन्ड 7, बट तुम अगर 5 मार्क्स का क्वेश्चन है 5 लिखा होगे तो बहुत होगा, बट एक बार सारे सुन लो. डेटा मॉडलिंग. Choosing an appropriate data model is crucial. It involves identifying entities, relationships, and attributes to represent the data accurately and efficiently. Designers must consider factors such as scalability, performance, and flexibility. So these are the factors that are considered while choosing appropriate model. So data modeling, like choosing the appropriate data model is necessary. DBMS selection. Selecting the right DBMS is essential. Different systems have varying features, performance characteristics, and scalability options. Factors like data volume, transaction requirements, and data access patterns must be considered while choosing a DBMS. Data integrity, data security, data access performance, data migration and integration, data versioning and evolution. Now let's read about data integration. Ensuring data integrity is crucial. So जैसे हमने ये 7 पॉइंट लिखे हैं तो सातों पॉइंट की फर्स्ट लाइन तो यही लिख देना लाइक डेटा चूजिंग द राइट डेटा मॉडल इज इम्पोर्टेंट चूजिंग द राइट DBMS is important. Data integrity is like ensuring data integrity is crucial. Protecting data from unauthorized access and ensuring confidentiality, integrity, and accessibility is significant concern. Designers must consider how data is accessed and optimized for performance. Like performance लिखा है तो performance first line में लिख दो like समझ रहे हो. Data migration and integration. When integration with existing systems or migrating data from legacy systems, designers need to plan and execute data migration strategies efficiently. As system evolve, the data layer should accommodate changes and versioning. So basically, these are the 7 points which are the issues in designing a data layer. Data layer क्या होती है ये हम अभी आगे पढ़ लेंगे तो डोंट वरी अबाउट इट बट ये आपको 7 इश्यूज में से कोई भी 5 इश्यूज पता होना चाहिए. बेसिकली सिक्योरिटी सबको पता होती है. वर्जनिंग एंड इवोल्यूशन ये भी बहुत इंपॉर्टेंट होता है हर चीज़ के लिए. इंटीग्रिटी DBMS सिलेक्शन ये याद कर लेना जल्दी से. तो लेट्स मूव ऑन टू द क्वेश्चन 4. Explain sliding window protocol in detail with example. So ये मैं बोलूँगी एक बहुत 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 इंपॉर्टेंट क्वेश्चन है. स्टार मार्क कर लेना इसको अगर तुम पढ़ रहे हो कहीं लिख रहे हो. मुझे पता है वो तो हो नहीं रहा होगा बट आफ्टर यू गेट दीज नोट्स इसको याद से पढ़ लेना बिकॉज मुझे याद है जब हमारा एग्ज़ाम हुआ था तो ये क्वेश्चन हमसे पूछा गया था एंड लाइक हमारे टीचर्स ने जब भी हमारा वाइवा वगैरह भी हुआ था तो भी ये बहुत इंपॉर्टेंट क्वेश्चन था जो सबसे पूछा गया था. The sliding window protocol is a technique used in computer networks to ensure reliable and efficient data transmission between a sender and a receiver. So it's a technique that is used between a sender and a receiver. इसके ये allow करता है हमारा data सही तरीके से transfer होने में. अभी हम आगे पढ़ते हैं कैसे होता है. It allows multiple data packets to be sent consequently without waiting for an acknowledgement for each packet. In sliding window protocol, the sender divides the data into smaller packets and assign a sequence number to each packet. So ये कैसे होता है ये अभी हम पढ़ रहे हैं. The sender maintains a window which is a range of sequence numbers representing the packets that can be sent without waiting for the acknowledgement. The receiver also maintains a window that indicates the expected sequence numbers of the packets it can accept. When a receiver receives a packet, it sends an acknowledgement back to the sender indicating the next expected sequence number. So इसमें basically होता क्या है, एक sender होता है वो अपना पूरे डेटा को पैकेट्स में डिवाइड कर देता है, उसको नंबरिंग कर देता है. फिर एक स्लाइडिंग विंडो क्रिएट होती है. इट्स बेसिकली अ नेटवर्क क्रिएट होता है जिसमें जो सेंडर होता है वो एक फ्यू रेंज मतलब समझो फॉर एग्जांपल अभी हम आगे देखेंगे बट मैं बता रही हूँ जैसे कि फॉर एग्जांपल हमने 3 स्लाइडिंग विंडो का अपना वो रखा है रेंज. तो कोई भी नेटवर्क में हम सेंडर जो है वो 3 पैकेट्स भेज देगा, पैकेट 1, 2 एंड 3 और वो 3 लगातार भेज सकता है विदाउट वेटिंग फॉर द एक्नॉलेजमेंट के रिसीवर को रिसीव हुआ कि नहीं. बट आफ्टर सेंडिंग द 3 पैकेट्स इट विल वेट फॉर द एक्नॉलेजमेंट ऑफ द रिसीवर. फिर रिसीवर बोलेगा हाँ भाई मेरे को पहले 1, 2 एंड 3 पैकेट्स मिल गए हैं तुम अगले भेजो. बट अगर रिसीवर को कोई प्रॉब्लम होगी बीच में लाइक समझो उसके पास 2 नहीं पहुंचा तो वो बोलेगा 2 वापस भेजो. देन वी विल सेंड 2 अगेन. देन वो बोलेगा कि 1, 2, 3 पहुंच गए अब मेरे को 4, 5, 6 भेजो. So this is basically the sliding window protocol. For example, let's consider a sliding window protocol with a window size of 4. Like मैंने अभी 3 window size का बताया, अब window size 4 का हम example देख लेते हैं. The sender packets numbered from 1 to 4. The receiver receives packets 1 and 2 and sends an acknowledgement with the expected sequence number 3. The sender's window slides and it can now send packet 5 to 8. The receiver acknowledges packets 3 and 4 and sends an acknowledgement with the expected sequence with 5. The process continues until all packets are successfully received and acknowledged. The sliding window protocols provides flow control and error control. Like ये याद कर लेना उसके क्या important है कि हम इसको क्यों पढ़ रहे हैं इस टेक्निक को. It allows for efficient use of network resources by enabling the sender to send multiple packets before waiting for acknowledgements. Additionally, it handles acknowledgements and transmissions to ensure reliable delivery of data. So these are the 3 things it does. Flow control संभालता है, error control संभालता है, ensures reliable delivery of data. So these are the 4 questions we did. Let's move on to the 5th. The 5th question is, how is flow control different from cognition control? Flow control refers to the technique and mechanisms employed to regulate the flow of data between communicating entities, typically in situations where the receiving entity cannot handle data at the same rate it is being transmitted. Flow control helps prevent data loss, cognition, and overload situation by ensuring the data is transmitted at a rate that can be effectively processed by the receiver. So जो flow control होता है वो basically receiver के कारण होता है, मतलब receiver के लिए होता है. तो receiver जो होता है वो cannot handle the data at the same rate, वो handle नहीं कर पाता है जो data आ रहा होता है receiver से. Like समझो कोई 2 लोग बात कर रहे हैं तो जो स्पीकर है वो बहुत फास्ट बोल रहा है, और समझो लाइक यू आर लिसनिंग टू मी, यू कैन नॉट इंटरप्रेट इट एट एज फास्टली एज आई एम सेइंग, तो वो प्रॉब्लम हो जाएगी. तो उस हिसाब से आप लोगों को स्पीड दी जाती है 1x 0.5x ऐसे, ताकि आप मुझे स्लो कर पाओ, ताकि आपके समझने की स्पीड मैच कर पाए जो सेंडर भेज रहा है. सो लाइक ये एग्जाम्पल टाइप ऑफ हो सकता है डेटा कंट्रोल. So second is cognition control. Cognition control relates to the regulation and control of cognitive processes in the human brain. Cognition control involves the mechanism by which individuals direct and manage their cognitive functions such as attention, memory, decision making, problem solving and other mental process. So basically cognition control एक human की ब्रेन फंक्शंस के अकॉर्डिंग होता है. फॉर एग्जांपल ये मेमोरी, डिसीजन मेकिंग, लाइक ये इस चीज़ के कंट्रोल को कॉग्निशन कंट्रोल कहते हैं. सो द नेक्स्ट क्वेश्चन इज डिफरेंस बिटवीन बिट रेट एंड बॉड रेट, एक्सप्लेन विद एन एग्जांपल. सो बिट रेट आप लोगों को पता होगा. बिट रेट refers to the number of bits that are transmitted or processed per unit time. It measures the data transfer rate and is usually expressed in bits per second (bps). Bitrate represents the actual amount of information that can be transmitted or processed in a given period of time. For example, if a network have a connection with a bitrate of 1 Mbps, it means 1 million bits can be transmitted in 1 second. Like समझ रहे हो कितना ज़्यादा डेटा ट्रांसमिट हो सकता है. सो बॉड रेट क्या होता है? बॉड रेट ऑन द अदर हैंड मीन्स द नंबर ऑफ सिग्नल्स पर सेकेंड इन अ कम्युनिकेशन चैनल. इट इज द सिंबल रेट ऑफ मॉड्यूलेशन रेट. इट इज द सिंबल रेट और मॉड्यूलेशन रेट. इसको और क्या क्या बोल सकते हैं? सिंबल रेट भी बोलते हैं, मॉड्यूलेशन रेट भी बोलते हैं. इंडिकेटिंग हाउ मेनी टाइम्स द सिग्नल चेंजेस state per second. Baud rate is typically expressed in baud or symbol per second (SPS). Baud rate is used to define the maximum achievable data transfer rate in a channel, but it does not directly correspond to the number of bits transmitted. Like ये इनका difference हो गया. In some cases, symbol may represent multiple bits. For instance, in old modern technology, a symbol could represent 2 bits using a technique called modulation. Modem ही होगा शायद. ये एक टेक्नोलॉजी होगी यार, तो मे भी गलती होगी मुझसे. Therefore, the bit rate may differ from baud rate. In summary, bit rate represents the number of bits transmitted, and while baud rate measures the number of signal changes per second. They are not always the same, especially when multiple bits are encoded in a single symbol. So basically, bit rate number of bits transmitted per second करता है, baud rate measures the number of signal changes per second. और baud rate में हम symbols per second को एक्सप्रेस करते हैं और सिम्बल्स मल्टीपल बिट्स पे एनकोड कर सकता है, इसीलिए बिट रेट और baud rate ऐसे डिफरेंट होता है. सो द नेक्स्ट क्वेश्चन, द 7th क्वेश्चन इज डिफरेंशिएट बिटवीन अडेप्टिव एंड नॉन अडेप्टिव राउटिंग एल्गोरिथम्स. So these are the two approaches used in computer networks to determine the paths for the data to travel from source to destination. जो हम डेटा भेज रहे हैं वो हमारे सोर्स से डेस्टिनेशन तक कैसे जाएगा, उसका पाथ क्या होगा. यही 2 अप्रोचेस होती हैं, अडेप्टिव एंड नॉन अडेप्टिव राउटिंग एल्गोरिथम्स. सो फर्स्टली adaptive routing algorithms. Adaptive routing algorithms dynamically adjust to the path for data transmission based on the current network conditions. So ये dynamically मतलब with time, मतलब with the process, जैसे process हो रहा होगा path, मतलब data transfer होने का, ये path अपने आप change करता जाता है according to the conditions. So dynamically adjust to the path for data transmission based on the current network conditions. Network कैसा है, कौन सा strongest है, like we will see. These algorithms continuously monitor factors such as network cognition, link failures and traffic load. तो जो सबसे अच्छा रास्ता मिलेगा उसके अकॉर्डिंग ये चेंज करते जाएंगे. कहीं नेटवर्क वीक है, सिग्नल वीक है, तो फिर वो तुरंत अपना पाथ डायनेमिकली चेंज कर लेगा, एडजस्ट कर लेगा. By analyzing the network state, adaptive routing algorithms make decisions on the fly to select the most efficient path. ये तुरंत एक विदिन जब काम हो रहा होता है तभी डिसीजन लेता है. Adaptive routing improves network performance by adapting to changing conditions and avoiding congested or faulty routes. For example, adaptive routing algorithms include distance vector routing, link state routing, and routing information protocol. ये different type of adaptive routing algorithms हैं. एक बार इसे बस याद कर लेना, ये important question है मेरे according, ये आ सकता है question में. Non-adaptive routing algorithms. So non-adaptive routing algorithms are predetermined or static routes that do not change based on real time. So ये according to हमारे network conditions वो change नहीं होंगे, ये पहले से ही defined path होते हैं. These algorithms rely on fixed routing tables or predefined paths that are configured manually or during network setup. Non-adaptive routing algorithms do not respond to changing in network conditions such as link failure or cognition. जो हमने routing algorithm में पढ़ा था, adaptive routing algorithm में ये सब वो नहीं करता है, basically सब उसका उल्टा करता है. तो non word आ रहा है exactly, तो फिर सब उसका उल्टा करता है. Non-adaptive routing algorithms are relatively simpler and require less computational overhead. Examples of non-adaptive routing algorithms include shortest path routing, flooding, spanning tree protocol and Ethernet networks. सबके दो दो एग्जाम्पल याद करें ना, इंपॉर्टेंट क्वेश्चन है. So the next question is 8th question. What is the difference between classless addressing and classful IP addressing? So classful addressing क्या होता है? Classful addressing is an addressing scheme used in the early days of internet. तो जो classful addressing होती है वो पहले यूज होती थी जब इंटरनेट नया नया आया था. It divided the available IP address space into three main classes: Class A, Class B, and Class C. The class determined the size of the network and the number of hosts that could be connected to it. Classful addressing relied on fixed length subnet. Fixed length subnet marks, meaning that the division between the network and host portions of the IP address was predetermined based on the class. This approach led to inefficient address allocation as it often resulted in wasted IP addressing. तो इसमें बेसिकली जो क्लास होती थी उसमें हम पहले से ही साइज ऑफ द नेटवर्क डिवाइड करके रख देते थे नंबर ऑफ होस्ट के अकॉर्डिंग, कि कितने नंबर ऑफ होस्ट किस क्लास में जाएंगे, किस साइज के अकॉर्डिंग डिवाइड होंगे. तो इसकी फिक्स लेंथ के कारण हमारे बहुत सारे आईपी एड्रेसेस वेस्ट हो रहे थे. तो इसीलिए हमने एक न्यू वो निकाली जिसको कहते हैं क्लासलेस आईपी एड्रेसिंग. क्लासलेस आईपी एड्रेसिंग ऑल्सो नोन एज क्लासलेस इंटर-डोमेन राउटिंग is a more flexible addressing scheme introduced to address the limitations of classful addressing. CIDR allows the variable length subnet mask, which means that the network portion and the host portion of the IP address can be configured independently, enabling more efficient allocations of IP addresses. With CIDR, address blocks of various sizes can be assigned, resulting in better address utilization and improving routing efficiency. तो बेसिकली क्लासलेस एड्रेसिंग में हम असाइन कर देते हैं अकॉर्डिंग टू जितना रिक्वायरमेंट होता है. बेसिकली ऐसे मान लो कि क्लासफुल में हम एक सेट ऑफ, समझो मैं एग्जांपल देती हूँ कि हमें किसी को भूख लगी है तो लाइक हम उसकी भूख के अकॉर्डिंग देंगे तो क्लासलेस अकॉर्डिंग. और अगर हम एक फिक्स अमाउंट देंगे जितना सबको मिलेगा, लाइक समझो 2 रोटी है वो सबको मिलेगी, तो वो होगी एग्जाम्पल क्लासफुल एड्रेसिंग के. क्लासलेस में जिसको जितनी भूख है, 1 रोटी की भूख है 1 लो, 3 रोटी की भूख है 3 है, 5 रोटी की भूख है तो 5 खा सकते हो. सो बेसिकली क्लासलेस मोड एफिशिएंट होता है. So let's move on to the next question, that is question 9. Explain the ATM reference model. Why does ATM use small fixed length cells? What is ATM signaling? So let's begin. The ATM is asynchronous transfer mode. ये याद रखना. Reference model is a framework that defines the architecture and functionality of ATM networks. It consists of 3 layers: physical layer, ATM layer, and AAL layer, that is ATM adaptive layer. So the physical layer defines a transmission medium, signaling and encode scheme used for transmitting ATM cells over the network infrastructure. It includes specifications for physical interfaces, transmission rates, and synchronization. The second layer is ATM layer. The ATM layer handles cell switching, routing, and addressing within the network. It encapsulates data into fixed length cells and determines the optimal path this for cell transmission based on network's routing and traffic management mechanism. The AAL layer. It provides the interface between the ATM layer and higher layer protocols or application. It adapts different types of traffic such as voice, video, or data into suitable formats for transmission over the ATM cell. ATM uses fixed-length cells, typically 53 byte in size, including a 5 byte header and a 48 byte payload. इसे याद करना, this is important. The use of fixed length cells offers several advantages. तो basically हमारा जो question था, why does an ATM uses small fixed length cells? इसका आंसर ये है. There are three advantages, that is efficient resource allocation, statistical multiplexing, and low delay and jitter. So basically fixed length cells allows for more efficient utilization of network resources. With a fixed size, ATM cells can be processed and switched more quickly, resulting in reduced processing overhead and improved network efficiency. तो जिस fixed size है उसके कारण it can be switched more quickly, resulting in statistical multiplexing. By using fixed length cells, ATM networks can employ statistical multiplexing, जो क्या होता है, where multiple data streams are interleaved and transmitted over the same network link. Statistical multiplexing enables more efficient sharing of available bandwidth among different connections, providing better overall network utilization. Low delay and jitter. It helps in achieving low delay and jitter characteristics, which are crucial for real-time application. Like जो network में problem आती है, like real-time applications, जब हम नेटवर्क यूज़ करते हैं वॉइस ट्रांसमिशन या वीडियो कॉल टाइम, तो जो प्रॉब्लम्स आती है वो अवॉइड हो सकती हैं इसके कारण, एटीएम स्मॉल सेल्स के कारण. द फिक्स साइज इंश्योर्स प्रेडिक्टेबल सेल ट्रांसमिशन टाइम, allowing for better quality and synchronization of real-time sensitive data. So ATM signaling refers to the process and protocols used in rules to establish, manage and release ATM connections between endpoints in the network. So ये एक short definition है जो हम याद कर सकते हैं. It involves signaling messages exchanging between ATM switches and endpoints to establish virtual circuits or connections for data transmission. ATM signal protocols such as ITU and Q2931 and Q931 facilitate the negotiation of connection parameters and addressing and other signaling related functions. Signaling in ATM enables the dynamic setup and teardown of connection based on the communication needs for the application or service. It allows for efficient resource allocation, connection management, and support for various QoS requirements within an ATM network. तो सिग्नलिंग क्यों ज़रूरी होता है, ये है. It allows for efficient resource allocation, connection management, and support various QoS requirements. Yeah, so these were the 9 questions we did, and let's do one more question and wrap this video up. Then we will continue in the next video. So the question 10 is, what is the need for an adaptive routing algorithm? Explain in detail. अभी हमने पढ़ा था routing algorithms 2 टाइप के होते हैं, adaptive और non adaptive. So adaptive में connection change हो जाता है dynamically जब data transfer होता है, और non adaptive में एक fixed path होता है जो पहले ही decide होता है जब network connection form हो रहा होता है. So these are the reasons कि ये ज़रूरी क्यों है, like what is the need for it. So these are the 5 main reasons: network topology changes, load balancing, quality of service support, fault tolerance, and scalability. In large-scale networks, topology can change frequently due to various factors such as link failures, cognition, or additional removal of network nodes. Adaptive routing can respond to these changes by dynamically rerouting packets along alternate paths, ensuring efficient and reliable data transmission. सो जो हमारा नेटवर्क होता है वो आपको पता है एक टोपोलॉजी कनेक्शंस में होता है डिफरेंट, जो रिंग मैश बस आप लोग को जानते होंगे. वील स्टडी दिस आगे के क्वेश्चंस में भी. सो बेसिकली जब नेटवर्क टोपोलॉजी चेंज होती है इन सब रीजंस के कारण, तो हमारा एडेप्टिव राउटिंग एल्गोरिथम बहुत हेल्पफुल होता है, इसीलिए हमें इसकी नीड होती है. Load balancing network often experience non-uniform traffic patterns where some links or nodes may become heavily cognited while others remain unutilized. Adaptive routing algorithms can distribute traffic across multiple paths based on the current network conditions, thus balancing the load and prevent bottlenecks. So, कई बार कई नेटवर्क पाथ से बहुत ज़्यादा डेटा ट्रांसफर होता है, कई अनयूटिलाइज होती है. सो बेसिकली हमारा ये एल्गोरिदम डिफरेंट पाथ से भेज सकता है हमारा डेटा. ज़रूरी नहीं है एक पाथ से ही सारा डेटा भेजे, और इसके कारण हमारा हेल्प होता है कि हम सारे नेटवर्क पाथ्स को इजीली इफेक्टिवली यूटिलाइज कर सकते हैं, और इससे लोड बैलेंस होता है और बॉटलनेक्स प्रिवेंट्स होते हैं. The quality of service support different types of network traffic such as real-time video streaming or file transfer may have varying QoS requirements in terms of bandwidth, latency and reliability. Adaptive routing algorithms can consider these requirements and select routes that meet the desired QoS requirements, optimizing network performance for different traffic types. For example, हम जब कॉल करते हैं तो हमारे को उतना अच्छा कनेक्शन नहीं चाहिए होता है एज कंपैरिजन टू जब हम वीडियो कॉल करते हैं. तो कई बार जब हमारा नेटवर्क उतना स्ट्रांग नहीं होता है तो हम वीडियो कॉल पे होते हैं तो हम काट देते हैं और ऐसे बोलते हैं कॉल ही कर ले, वीडियो कॉल सही से नहीं चल रहा है. सो दिस इज क्वालिटी सर्विस मैनेजमेंट, जो हमारा अडेप्टिव राउटिंग एल्गोरिथम अपने आप संभाल लेता है. जहाँ नेटवर्क अच्छा होता है वो वीडियो कॉल का डेटा सेंड कर सकता है, और जहाँ पे उतना कंपैरेटिवली अच्छा नहीं होता है वो नॉर्मल कॉल्स का सेंड कर सकता है. सो द फोर्थ पॉइंट इज फॉल्ट टॉलरेंस. नेटवर्क फेलियर कैन अकर अनप्रिडिक्टेबली लीडिंग टू डिसरप्शन ऑफ डेटा ट्रांसमिशन. Adaptive routing algorithms can detect and avoid failure or cognitive links by dynamically rerouting traffic through alternate paths, thereby improving the network fault tolerance and ensuring uninterrupted communication. And the fifth point is scalability. As network grow in size and complexity with an increased number of nodes and connections, the routing decisions become more challenging. Adaptive routing algorithms can adapt to changing network dynamics and scale efficiently by considering local and global network information, making routing decisions based on real-time conditions. Overall, the need for adaptive routing algorithm arises from the dynamic nature of networks and the requirements for efficient source utilization. The support of diverse traffic types and QoS parameters, fault tolerance, and the scalability of the network infrastructure. By dynamically adapting to the network conditions, adaptive routing algorithms contribute to improved performance, reliability, and flexibility in data transmission within computer networks. So this was your question 10. So we have done 10 questions on the subject of computer networks. Let's continue in the next video. Thank you for watching.